So this is section 3.3, dividing polynomials. And although we're going to start off with an example of this like long division polynomial, it's not what you're going to see the most in the future. So we'll go over this example and then we'll start showing how it's actually useful to us, this version of long division. So when we say divide a polynomial by another polynomial, it is literally the same thing as having x cubed minus 3x squared plus 2x plus 2 divided by, division sign, x squared plus 1. Same thing. Now, this top piece here is called the dividend. And what we're dividing by is called the divisor. So this is just notation here. Now, what that looks like with our division kind of symbol here that we have is that we're taking the x cubed minus 3x squared plus 2x plus 2, and we're dividing it by x squared plus 1. So the first thing that we ask ourselves here is what times x squared will give us x cubed? So we're thinking about the first term that we have underneath our division sign here is what would that be? And whereas with numbers, you're trying to get as close as possible, here you're going to be able to do that exactly. You know that x times x squared gives you x cubed. So this becomes your, your quotient and what we put on the top. So now we're going to take x and multiply it by x squared to get x cubed. We're going to take x times 1 and we get plus 1. I want to keep my like terms together. So I'm not going to put a minus 3x squared. I'm not going to put the x underneath that because I need to be able to do some subtraction and I can only subtract things that are like terms. So I end up with this. And then when we subtract, what you're going to notice is that first term's always going to go away. If you're doing it correctly, that should be gone. So now you have a negative 3x squared. And then, because I'm subtracting 0 from that, then I have 2x minus x. So notice that's just going to give you a positive x, and then you'll have plus 2. Now you start all over again, and now you're just focusing on still that x squared, still your divisor, still the x squared, but now the minus 3x squared. So you're asking yourself, what times x squared would give you a minus 3x squared? And the answer to that, of course, is a minus 3. Now we multiply, just like we did before, negative 3x squared minus, and then notice that it's a minus 3 over here. I don't have anything that's underneath my x because there's no like term there. So now, however, we do have what we need, so we're going to subtract. And again, that should be gone. That first term is gone. X, I'm subtracting nothing from that. I have 2 minus a negative 3. That's going to give me 5. Okay, x plus 5. So what that is, what this means, is that when we take that polynomial and divide it by x squared plus 1, we get x minus 3 plus a remainder. So this x plus 5 is our remainder. Remainder, and that gets divided by our divisor. Okay, and then this piece here, this x minus 3, is what's called the quotient, because we are doing division. So those are all the pieces of it. That's the terminology that we use, but that is actually the answer to the division. Now, understand that if you were to multiply both sides of what I have here by x squared plus 1, I'm just saying, like, there's no reason for us to do that. But if you were to do that, I want you to understand that the left side would just be what you started with, your dividend. And the right side would actually end up being the same thing. So when you multiply x squared plus 1 times x minus 3, you get that whole dividend except for the x plus 5. and then you would add x plus 5 to it, and then that's going to give you that dividend at the top. So the two sides are equal. You're just rewriting it by doing the division, essentially. Now, this is an example more of what you're likely to see or need to do, I guess I should say. There might be situations within calculus where you need to do something like this. We'll talk about that more. This is more likely because you have a linear factor. So I want you to see that you're dividing by x minus 2. X has a degree of 1. Now the work is still going to be very similar to what we're doing, but you'll notice some small differences based on this. So notice that we have cubed, squared, power of 1, and then no variable. So when we start this, we're going to ask ourselves the same question: what times x gives me x cubed? So it's still thinking of the first term in the divisor and the first term in the dividend. We know that that would be an x squared. Now we're going to line things up. So I'm going to multiply the x squared times the divisor. And that's going to bring me here. And then just like we just did, we subtract both of those. Notice everything's lining up so far. I don't have any blank things underneath my dividend. So again, that's going to be gone. That should always be what happens. I get 2x squared minus a 2x squared. That's going to give me 4x squared. Don't know why that threw me for a second. And then I'll have a minus x. Okay. Now I am ready to do the next division because I know that I can line things up underneath both of these. So now I ask the question, what times x gives me 4x squared? That's going to be plus a 4x. I multiply, again, I'm going to be lining up everything. Notice everything has something underneath it, so that's great. Okay, we see what we get. So it looks like we get 4x squared minus 4x squared, gone, always should happen. Negative x minus a negative 8x, negative x plus 8x is 7x. So now we have 7x. I still need to bring down, so notice I brought down the x here. I'm bringing down the 4 plus 4. And then we will have the last question, which is what times x gives me 7x? So that's going to be a plus 7. So now I have 7x minus 14. And then gone, because I'm subtracting. And it looks like I'm going to have 18. Okay, so here is our solution. Here is the answer that we got. And again, this can be written in a couple different ways. So understand that what we're saying is x squared plus 4x, let me write that slightly differently. All right, so let's start from the top here, which is x cubed minus 2x squared minus x plus 4 divided by x minus 2. So we have that equals x squared plus 4x plus 7 plus the remainder of 18, which is over the divisor. Now what I want you to see, kind of what I was trying to say before, is that's the same as saying if I multiply both sides by x minus 2, x cubed minus 2x squared minus x plus 4. So if I multiply both sides by x minus 2, I get my quotient times x minus 2 plus 18. So I just want you to see that these are equivalent ways to write these two things. One is showing the division by the divisor. The other one is I've multiplied through by the divisor just to show a different way to look at it. But like I said, they are equivalent answers here. But I think we can see that this is a lot of work. This is a whole lot of work. So another way, when you have the divisor of the form x minus r, so understand that we had x minus 2 in that last example. I mean, you have it right there. I have it on the last slide. But when you're dividing by a linear factor like this, x minus 2, you can actually do something called synthetic division. And this is the thing that can be very useful to you and the thing that you should focus on. So when you do this, so what we're going to do is we're going to take the example from the middle of the page, the one we just did, and we're going to use synthetic division. So notice what it says is we're going to drop the x's. So we're going to get rid of all of our variables for a little bit. We're going to bring them back because we want the answer is going to be the same as what we just got. But we're going to get rid of those variables to start. So the first thing that we do is we think about our divisor x minus 2. In this case, understand that that means that r equals 2. So our divisor is 2. So that's what I'm going to put here. Place the coefficients in the dividend in a row next to the box. So taking a look at our last example, we had x cubed, so the coefficient was 1. We had 2x squared. We had a minus x, and we had positive 4. So here are my coefficients from what my dividend, the thing that we're dividing into. Okay. Then it says, copy the leading coefficient into the third row. So this 1 comes down, and it's right there. Okay, now here is what we do. It's actually very straightforward, and it mimics what we've done, but just without all the variables in it. So it's really kind of nice. So what we do is we take our 2, we multiply it by 1, we place it underneath here. That's all you have to do, and then you just add. And then you repeat 2 times 4 right here, and add. 2 times 7 right here, add. You're done, okay? That's pretty fantastic. You have to be able to interpret it, like what this means, but it does work. So you should notice these numbers are actually, when you think about our answer, you should see these numbers happening. So what happens is because we had x cubed and we divided by x, it means that our first term is an x squared. So now we're going to have x squared. We're going to have plus 4x. So notice I'm going down. My variable is going down in terms of its degree. So I have degree 2, degree 1, degree 0, x to the 0. And then we have our remainder. So please notice we have the same answer that we got before. It's the same exact answer, but it was so much faster than what we did with all the variables in it. So as long as you know how to interpret it, this is a very helpful thing. And we'll look at some more examples because it does get faster as you practice.